The third and final method of solving a system of equations is using elimination. So elimination is best used if all of the variables have a coefficient other than 1. It is also best used when both equations are written in the exact same form. So I'll explain what that means in a second. So in example 1, it says solve this linear system using elimination. So because it specifies elimination, that's the method I'm going to use. However, if I was given the option to use elimination or substitution, for this one, I would probably choose substitution because there's a lot of coefficients that are equal to 1 here. So that makes it easy for us to solve for one of the variables and substitute it into the other equation. But it specifies to use elimination, so that's the one we're going to use. Now, it also says that it's best used when both equations are written in the exact same form. And what I mean by that is all the x's line up and the y's line up and then the constants line up. And they have to be on the same side of the equal sign. So you'll notice that we have our terms with the x and then our terms with the y's, and then we have our equal signs right here, and then our constant terms. So both of these equations are written in the exact same way. Now, our next step, or our first step when we're using elimination, is we want to eliminate one of the variables by adding or subtracting the equations together. You'll notice that we have 1y in the first equation and 1y in the second equation. So it would be really easy for us to eliminate one of those y's by subtracting one equation from the other. So I'm just going to put here that because the coefficients of y are equal, we are going to subtract the equations. So we're going to subtract the equation. So this is how we're going to set it up. We're going to have 2x plus y is equal to -7. And then right below it, we're going to put our second equation, x plus y is equal to -4. And now I'm going to subtract our bottom equation, or equation number 2, from the top equation. So I'm going to put brackets around the entire second equation. I'm going to put a little minus sign next to it, meaning that we're going to subtract these two equations. So now we're going to subtract like terms, and our goal here is to eliminate one of the variables. So we have 2x minus x. First, we're looking at these two right here, 2x minus x. So that would leave us with just 1x, or just x. And then the next one, we have y minus y. So in this case, we are going to end up with 0, so plus 0, because y minus y is equal to 0. It eliminates that variable. And then we have equal to -7 minus -4. So be careful there because we have a double negative, minus -4. So that's going to bring us to -3. So then in other words, we would just have that x is equal to -3. So there we go, we already solved for one of the variables. So now what we're going to do is we're going to plug that x is equal to -3 into one of the equations. It doesn't matter which one you use. I'm just going to do equation number 1. So I'll plug x is equal to -3 into 1. So then we'll have 2x plus y is equal to -7. And then we are going to plug in that x is -3. And then plus y is equal to -7. So -6 plus y is equal to -7. And then finally, we're going to add 6 to both sides of the equal sign. So we will get that y is equal to -1. So our solution for this one is -3, -1. And we are going to verify that. So I'm going to do my left-hand side, right-hand side for both of the equations. And I'm going to plug in -3, -1 into both of them to see if we get both sides being equal to each other. So I'm just going to skip ahead while I do that. Okay, so I plugged in -3 and -1 into both of the equations, and it does work. So we're just going to write down here that therefore the solution is -3, -1. So that's how we use the elimination method. So in the second example, it's a pretty similar question. It says solve this linear system using elimination and verify your answer. Now you'll notice with this one that no terms or no like terms have the same coefficients. So because none of the coefficients are the same, it's going to be really hard for us to cancel out or eliminate one of those variables if we were to add or subtract the equations. So because of that, we need to make one of the variables have the same coefficients as each other. So let's just focus on the coefficients in front of the x's and let's make those the same. So we're going to make the coefficients in front of the x's the same. And in order to do that, we need to think of the least common multiple of the 3 and the 5 that are already in front of those two x's. So least common multiple of 3 and 5 is 15. So what we're going to do here is we are going to take our first equation and we need to get that 3x to turn into 15x. So what do we have to multiply that by? It would be a 5. So we're going to do 5 times the entire equation. And make sure you multiply the entire thing to keep it all even or equal. And then the next one, we need that 5x to turn into 15x. So we are going to multiply that one by 3. But we have to multiply that entire equation. So if we were to do that, we would get 15x minus 20y is equal to 35 for the first one. We'll call this one 1b. So that's equation 1b. And then for equation number 2, we would get 15x minus 18y is equal to 24, and we'll call that 2b. So now we have the same coefficient in front of one of the variables, in front of the x's. So now we are going to eliminate that variable. So I'm going to do my whole thing here. And in order to eliminate it, we would have to do 15x minus 15x. So we are going to subtract these two equations. So 15x minus 15x is 0. Then we are going to have negative 20y minus 18y. So careful, there is a double negative there. So we would have minus 2y after we do that double negative, because that would become minus 20y plus 18y. And then we have 35 minus 24. So that would be 11. So now we eliminated the x's, and what we have to do now is solve for y. So then I'm going to divide both sides by negative 2, and you should get that y is equal to negative 11 over 2. Okay, so I just wrote 2 more steps there that we subtracted to eliminate x, and then we solved for y. And in our next step, we are going to plug this value we got for y into equation number 1. So I'm just going to write here, plug y is equal to negative 11 over 2 into number 1. And then we are going to solve for x. So here's our equation number 1. So I'm going to replace our y with negative 11 over 2, and that's equal to 7. And then we are just going to solve for x. So first I'm just going to get rid of these brackets. So negative 4 times negative 11 over 2, that would be plus 44 over 2, because the two negatives multiplied would make a positive. And then that simplifies really nicely. 44 divided by 2 is 22. And then we are just going to subtract 22 from both sides of the equal sign. So we'd get 3x is equal to negative 15, and then we would divide by 3 on both sides. So our final answer will be x is equal to negative 5. So there's our solution. Now all we have to do is verify that it is correct. All right, so I did the left-hand side, right-hand side verification for both equations, number 1 and number 2 in blue here, and it worked on both of them with that solution we got. So our solution is negative 5 and negative 11 over 2. Now in the final example, it says solve this linear system using elimination, and again we have one of those systems with a bunch of fractions in it. Now, this time we actually have an option, and we are going to get rid of the fractions. Because if we get rid of the fractions, it's going to make it a lot easier for us to work with. So, in order to get rid of the fractions, we need to get rid of the denominators. And in order to do that, we need to multiply each equation by the least common denominator, or the lowest common denominator. So if we're looking for the least common denominator of number 1, it would be between the 3 and the 2, it would be a 6. And then if we're looking for the least common denominator for number 2, we're looking at the 2, 4, and 2. So there the least common denominator would be a 4. So what we're going to do is we're going to multiply both of our equations by that least common denominator to just get rid of those fractions altogether. So from that, we are going to do equation number 1 here. I'm going to multiply the whole thing by 6. So I'm going to take a 6 and I'm going to multiply it to the entire equation. So we're going to have 2 over 3x minus 1 over 2y is equal to 4. And then we're going to multiply our second equation by 4. So we're going to have 4 times 1 over 2x plus 1 over 4y is equal to 5 over 2. So from there, this is what it's going to turn into. So we have to distribute these numbers into the brackets. So we are going to have 12 over 3x minus 6 over 2y is equal to 24. And then for the second one, we are going to have 4 over 2x plus 4 over 4y is equal to 20 over 2. And now in the next step, we are definitely able to cancel out those denominators. So for equation number 1 here, we will have 12 divided by 3 is 4. So 4x minus 3y is equal to 24. So that one cleaned up pretty nicely. And then the second equation here, we have 4 divided by 2 is 2x. And then plus 4 divided by 4 is just 1y, or y, is equal to 10. So now we have our two different equations. They're equal to our original equations, but they're slightly different. So I'm going to name this one 2b, and then the one on top of it 1b. So now that we got rid of those denominators, we need to eliminate a variable. So right now we have no coefficients that are the same. So our first step is to get either both y terms or both x terms to have the same coefficient. So if I'm looking at these equations here, we can either get both the x coefficients to be the same, and in order to do that, I would just multiply the second equation by 2, because then we would have 4x in both of them, or we can get both of the y terms to have the same coefficient. So I'm going to do both of the y terms. So if I were to multiply the second equation by 3, then both the y terms would have a coefficient of 3. So for equation 1b, we can leave that one the same. It would be 4x minus 3y is equal to 24. And then for equation 2b, I'm going to multiply the entire thing by 3, because when I do that, I'm going to have a 3 in front of that y value. So I'm just going to rewrite these down. So equation 1b stays the exact same, but now equation 2b changes to 6x plus 3y is equal to 30. So now we have the same coefficient in front of the y values. They're both the number 3. So now we can easily eliminate by adding the equations together this time. So in the other two examples, we subtracted the equations, but you'll notice this time, if we were to add them together, we would have negative 3y plus 3y, and that would cancel them out. So we are going to eliminate y by adding the equations together. So I'll just do it in this step right here. So we'll put a nice set of brackets around the second one, and we are going to this time add them together. So 4x plus 6x is equal to 10x minus 3y plus 3y is equal to 0. So we have plus 0 is equal to 24 plus 30 is 54. So in other words, 10x is equal to 54, and we are going to get a fraction this time, 54 over 10, or in other words, x is equal to 27 over 5. So now that we solved for x, we need to plug that into equation number 1 and solve for y. So I'm going to do that, and I'm going to skip ahead so you don't have to watch me do all of those steps. All right, so I plugged our x is equal to 27 over 5 into equation number 1, as you can see at the top right over here. And then I worked my way down, trying to isolate y to get it all by itself. We needed to get a common denominator at this point in order to combine these two like terms. So it got a little bit messy, but it's not too bad. And in the end, we get that y is equal to negative 4 over 5. Now, of course, you should be verifying your answer for this one, but I'm not going to do that step. If you want to verify that answer, feel free. But this is the solution for this question.